So why can't I use degrees Celsius when using the gas laws? The reason is degrees Celsius has negative values. So let me show you what I mean. Let's pretend I have a balloon and it's in a 10 degrees Celsius room and we don't know what the volume is, and the balloon is brought to a cold room. Let's say it's colder than 10 degrees, it's below zero, negative 10 degrees Celsius, very cold, below freezing point, and this volume is 1 liters. If we take that balloon from cold room to a hot room, the balloon will expand because the molecules will have enough energy to push against the inside of the balloon to make it bigger. But what would the volume be? So which gas law should we use? Okay, so this is temperature versus volume, right? Temperature versus volume. So I'm going to use the TV. The way I remember the TV would be, this is how I remember these laws. TV, Charlie Brown is on TV. So I would use Charles' law. Our vice president has boils. It's a skin disease. Guy Lucé uses toilet paper. And this one's easy because Avogadro is moles. Okay, so this is the relationship between T and V, so it's Charles' law. Charles' law is a direct relationship, T1 over V1 equals T2 over V2. T1 over V1 is equal to T2 over V2. So initially it was, the temperature is negative 10 degrees. Oh no, I'm not going to use that one. I'm going to use it, actually it doesn't matter, but the book uses the V on the top. V1, T1, you'll get the same answer, equals to V2 over T2. Okay, so the V is 1 liter initially, and the temperature is negative 10 degrees Celsius. Equals, the next volume, this is V1, T1, this is V2, T2. The next volume is unknown, so that's X. And it's at a hotter room, 10 degrees Celsius. Okay, so now I'm about to solve for X. First, let's predict what the answer would be. If it was 1 liter in the cold room, what do you think it's going to be in the hotter room? Is it going to be bigger or smaller? It's going to be bigger, right? So it's going to be bigger than 1. So let's see if we get a number bigger than 1 liter. Okay, so cross multiply this. I'm going to get negative 10x equals 10. Divide by negative 10 on both sides. X is equal to 1. Okay, that is, the unit here is liters. So this will be negative 1. It'll be negative 1 liter. Negative 1 liter means it's smaller than 0 liters. You can't have a negative liters. Okay, which means you can't use negative values for degrees Celsius because it's not proportional. These two numbers, 10 and 10, the absolute numbers are pretty much the same. So you can't use that. So what you have to do is you have to change this to Kelvin. So this negative 10 is really plus 273. You're going to get the Kelvin of 263 Kelvin. This is plus 273. You're going to get 283 Kelvin. So 10 plus 273 is 283. Negative 10 plus 273 is 263. So the difference between this temperature and this is a value of 20. Negative 10 to 0, and then 0 to 10, that's 20 absolute temperature units. So 263 to 283 is really 20 absolute temperature units. And Kelvin is the absolute temperature unit. That's why you must use that. So when you plugged it in, you use 1 liter over 263 equals X over 283. And you can already see that as the 263 goes to 283, it'll go up. The 1 liter will also go up. Okay, so let's solve this problem. Cross multiply. 263x is equal to 1 times 283, which is 283. Divide by 263 on both sides. X is going to be 283 divided by 263 equals 1.08 liters. Does that number make sense? Does the balloon get bigger when you put it into a hotter room? 1.08 liters. It does. It goes from 1 liter to 1.08 liters. Okay, so this is why you cannot use negative values.